Hi, welcome to the video solution for Edexcel Physics. This is Edexcel GCE Physics, June 2019, Unit 1 for A-Level exam. So let's start. Question number 1. Which of the following particle is an example of fundamental particle? So if you see the fundamental particle are categorized into two types. Ones are called leptons and the other one are called quarks. So we have 6 quarks and 6 leptons. So those particles which are made from quarks, those are called uh, hadrons. If you see the list, nucleus composed of proton and neutron, it cannot be fundamental. Proton composed of 3 quarks cannot be fundamental. Pine composed of 2 quarks cannot be fundamental, and neutrino belongs to lepton family. So in this list, neutrino is fundamental particle. Question number 2. A person uses a pivoted lever to lift a boulder of weight W as shown. It is a boulder, weight W, distance D is given, pivot, okay. The center of gravity of the boulder is at distance D from the pivot. The angle of the lever to the horizontal is theta, which expression is equal to the moment of W about the pivot. So if you see moment we find using just force multiply by perpendicular distance. So F into D gives us moment, but remember this formula is only used if uh, force is perpendicular. If you say this is force acting and this is pivot and this is pivot distance or moment arm, and if you see the angle between force and D, it is 90 degree, then we can use F into D. So we know that in our given situation, W is going to produce moment, and due to W, this plank or this lever is going to be rotated in that direction, meaning clockwise about the pivot. But we cannot say W and D will gives us moment. So WD cannot be moment. The reason is W and D are not at 90 degree. So in this case, we will have to find component of either W or D. And in this situation, if you see this is uh, D, here I'm drawing with it, so with this reference to pivot. So this is D. And if this is D, clearly if I say this angle would be theta. Same situation. This red line is parallel to the lever and the dotted line parallel to the to this, so the blue one. So if this angle is theta, that's this angle will be theta. So now in this case we can resolve D into its component. And how do you do that? So you have this vertical component and horizontal component. So this D is resolved into component, and clearly if you see you have a right triangle something like this. This is D given there, and this angle is theta, and this is adjacent, so that will be D cos theta. So if you see the component of D, which is D cos theta here, D cos theta, this D cos theta is perpendicular to W. So if you need to find the moment, you need to multiply W with d cos theta. So W into d cos theta will be the moment produced by W. So your option is B. Question number 3. A space rocket lifts off vertically. The rocket lifts off because the exhaust gases exerts a force on the ground. The exhaust gases exerts a force on the rocket. The ground exerts a force on the rocket, and the rocket exerts force on the ground. Clearly, this is in fact Newton third law pair of forces. So when rocket moves up, rocket is applying force on the ejected gases in a downward direction. Then according to Newton's third law, the ejected gases applies force on the rocket. So that's what you need to realize, that the exhaust gases exert force on the rocket. This is the force due to which rocket lifts off. So your option is B. Question number 4. A circuit consists of three identical 1.5 volt bulbs connected to two 1.45 volt cells. The switch is closed. Which row describe the change in brightness of bulb Y and the bulb Z? Okay, so if you need to relate brightness of the bulb, then you need to see whether the bulbs are in parallel or in series. So if you see the circuit, X and Y, both bulbs are in parallel, and they have identical resistance, same resistance. All the three bulbs have same resistances. So if you see these X and Y are in series with the Z, or with the bulb Z, whatever you call it. So Z is in series with the X and Y. Clearly, in parallel, overall resistance is decreased, because if you use two resistances, R1 and R2, in parallel, and someone asks what is the total resistance, so you say that the total resistance R must be less than R1, or are also less than R2. So overall resistance is decreased. So X and Y, both bulbs are in parallel. So overall resistance of this loop, or this this side of the circuit, is less than the resistance of the Z. Meaning Z has high resistance. That means resistance is high, so the voltage is high. Voltage gain or voltage draw, energy received, is high. Voltage of Z, Vz, is higher. That means Z will be brighter than X and Y. So Z will be brighter. So if you see the option Z, we might have option A, because this is brighter and this is brighter. But we cannot have dimmer Z, so we cannot waste time on B and D. So we have to choose either A or C. Now clearly the volt, because resistance is less and these two are in series, so overall resistance is less, so voltage across X and Y, so voltage across X and Y will be less than voltage across Z because of the low resistance. That means brightness of X and Y will be less. So it's about Y. So Y will be dimmer than Z. So your option is C. Question number 5. A cell of EMF 1.5 volt is connected to a 5 ohm resistor. The terminal potential difference across the cell is 1. Which of the following is the current in the circuit? Now, there is a small twist in this question, because if you need to find current passing through uh, the circuit, so if you need to find I, so you need that resistance R, which is in fact, this is 5 ohm resistance. So R is 5 ohm. R is 5 ohm, and you need the voltage to figure out current, and V is equal to IR. That's what you know according to Ohm's law. So I is equal to V by R. What about V? Because we are given two different voltages, 1.5 volt and 1 volt. And what are they saying? They say that 1.5 volt is EMF, while 1 volt is terminal potential difference across the cell. So the terminal potential difference, so EMF is 1.5. If this is the cell, suppose if this is the cell, then EMF is 1.5, but after losing lost volt or energy inside due to internal resistance, the output voltage or the terminal potential difference, which is V, and the same voltage comes across the resistor R. So terminal potential, we can say it is terminal potential difference across the cell, or we can say same for across the resistor. So voltage across the resistor V would be equal to terminal potential difference. So we have to use here 1, not 1.5. So I would be equal to 1 divided by 5. That means 0.2. So your option is B. Question number 6. The diagram shows a graph of current I against potential difference V for an electrical component. This is IV graph. Which of the following component would produce graph of this shape? So we have uh, 4 graph to understand, uh, generally comes in exam. So first graph is, suppose VI, and if you have this shape of curve, and you can have IV graph of that, of this shape. So difference between these two graphs are here in the first graph, gradient of the graph is increasing. See, gradient is increasing because it is a curved up. So gradient increases. That means resistance is increasing, because gradient of VI graph, gradient of VI graph is V upon I, which is R. So gradient equal to R. Gradient increasing, so the resistance increasing. And here, if you find the gradient of this graph, so gradient of this graph will be I upon V, which is 1 upon R. That means 1 upon R, or resistance, would be equal to 1 upon gradient for that particular shape. So gradient is decreasing. IV graph, gradient is decreasing. That means resistance is still increasing. And these two graphs are for filament lamp. For filament lamp. We have two more graph to understand. Suppose we have VI graph, instead of curved up, it is curved down, and IV graph curved up other than curved down. So what is happening here? The gradient of this graph is decreasing. Gradient decreasing, that means resistance is decreasing. And here gradient is increasing, So resistance again decreasing. And these two graphs are typical for thermistor. Thermistor, or you say negative temperature coefficient. So if you see the given graph, IV graph, it is curved up, something like this. You see that. So that means this IV graph, gradient increasing, resistance decreasing. So it cannot be the graph of filament lamp. Metallic conductor, we must have a straight line. Ohmic conductor is as same as metallic conductor. We can expect a straight line, curved, but for these shape. So the remaining option is negative temperature coefficient or thermistor. So option is C. Question number 7. The force between two identical point charges x and y is F. Charge x is double, charge y remains the same. Which row of the table gives force on each charge? A straightforward question. You know we have a two charges q1, q2, q1, q2 separated by some distance r. So the force between two charges is F is equal to k q1 q2 upon r square. And from this equation you know that force is force is directly proportional to product of the charges, and force is inversely proportional to the square of the distance between the two charges. Clearly, if you see this statement, force is proportional to product of the charges. If any one of the charge is double, then force must be double. So they are saying that charge x is double. So if charge x is double, so force must be double for x here. So you cannot have A and B. You need to choose either C or D, looking at only the first column. But you know that the force applied on charge q1 or force applied on charge q2, both force will be same. So if due to doubling of x, force on the charge x is doubled, then force of the charge on y, force on the charge y is also doubled. So your option must be D. Question number 8. A capacitor of capacitance C is discharged through a resistor of resistance R. The initial discharge current is 1 I naught. Which of the following expression gives the current after time equal to RC? Quite easy question. If you have a concept of this RC, remember RC is the called time constant. Time constant, and denoted generally we use symbol something like tau. So tau is equal to RC. This is time constant. And what is time constant? Time constant is the time at which the current or the voltage decrease by 37%. 37% of I naught. And if you see this 30% is in fact 0.37%. And if you remember the derivation of this time constant, this 0.37 is obtained by dividing 1 with e exponential. So 1 upon e, you can check your calculator, 1 upon e gives you 0.37. That's why we say that either current is decreased by 37% or 0.37 times, or we say 1 upon e times. So if you see we have initial current of I naught, and after time RC or the time constant, the current is decreased by I by A naught. So A option is A. Question number 9. A rectangular sheet of aluminum is attached to an air track glider as shown. The glider moves towards a region of uniform magnetic field at a constant velocity. When the glider enters in the magnetic field, the magnetic flux is perpendicular to the aluminum sheet. So this is aluminum sheet, constant moving with constant velocity, magnetic field region, and when it is moving, it will enter in this region. And remember, magnetic field is uniform. Okay, which row of the table describe the velocity of glider as it enters the magnetic field? When it is completely within the field and when as it leaves the magnetic field. So we need to find uh, the change in velocity. Describe the what happened to the velocity when it enters the field, within the field, and leaving the field. So remember, when the the glider is moving with a constant velocity here. As soon as the glider reaches into the magnetic field and start entering, you know, uh, the flux of this uh, aluminum sheet changes, so EMF is induced. And according to Lenz's law, the EMF is always opposed the cause that is producing it. That means due to Lenz's law, an opposing force generates or exerts on this glider in order to reduce the velocity according to Lenz's law. So that means when it is entering, it should be decreasing velocity. So you cannot have a, and during entering, so you cannot have a constant when entering the field. So you, all these fields are decreasing, velocity is decreasing. What about within the field? When the glider is passing within the field, magnetic field is uniform, so the velocity remains constant within the region. That means your option A is gone. So you have either B or C, because here the flux is constant for the sheet. So it will be moving with a constant velocity. When it is exiting from the field, when it is coming out, again, flux starts changing. So EMF is induced, and EMF induced because it is leaving with some constant velocity. So it is trying to stop the glider in order to not to go out. So again, the velocity is going to decrease rather than increase. So your option is C. So when it is entering, decreasing velocity, within the field is constant. When it is coming out, due to Lenz's law, you have a decreasing velocity. So option is C. Question number 10, the solid line shows the path of an alpha particle as it passes close to a nucleus. So this is solid line, alpha particle here. Another alpha particle approaches the nucleus with the same kinetic energy. Which dash path is possible for this alpha particle? Okay, so idea is, if you see, you should not waste time on path A and B. The reason is, if you see, the solid line, which is alpha particle, starts deflecting from that position, but part A is deflecting after that. So that means it has more energy, and plus it is a positive charge, so it should move away, not coming towards the nucleus. So you cannot have A. Even option B starts deflecting from this position. That means at B, the alpha particle must has high kinetic energy, or moving with high speed. So you cannot have A and B. Most probably, because if you see the C path of the C, it start deflecting at the same position like our previous alpha particle. And as because it is coming closer to the nucleus, so it deflects more than the solid one. So you must have option C. And what about D? If you D again is start deflecting from this point. That means the d at d alpha particle must has high kinetic energy. So your option must be C. Question number 11. A track for toy cars can be built with a circular loop as shown. A toy car is placed on the track at various height. It travels around the loop before leaving the track horizontally at x. The loop has a radius r and the mass of the toy car is m. It is possible for a toy car to complete the loop without losing contact with the inside of the track. For this to occur, minimum speed of the toy car at the top of the loop v top is given by, so minimum speed at the top of the loop. So if you see the diagram, and this is the track which is joined with the loop. So what happened if you put a car here and the car slide down along the track and then take the loop and then come out from something like this. So the car complete the circular loop. So what are they saying? They are saying for this to occur, minimum speed of the toy car at the top of the loop, meaning if the car is here, then the velocity of the car is given by this equation. How do we get this equation at the top of the loop? You know, this is a circular loop, and at this point the only force acting on the car is the weight W, and this W is in fact centripetal force. So you say that W is equal to m v square over r, where m is the mass of the car. So W is mg, mv square over r. So m gets cancelled. So clearly v square is equal to gr and v is equal to gr root. And this is the velocity at the top of the loop. That's why you can use v top if you wish. Part B. The toy car just complete the loop without losing contact with the track. Show that the speed of the toy car at the bottom of the loop is about 3 meters per second. Radius is 0.15 meter. So if you see this situation, if you recall the diagram, you have a loop. Just look at the loop, and this is the point x where the car is leaving the track. We need to find the velocity at that point. I'm just calling it velocity v at the bottom. That's what we need to find. And what about the rest of the situation? So if you see, the car is coming from top of the loop, coming something like this and going out. So we will use law of conservation of energy, because the car has two types of energy. At the top loop, we have proved that the car is moving with the velocity v top or vt, which is you prove rg. That means the car must has kinetic energy at that moment. So the car has kinetic energy, and this kinetic energy can be written as half of m vt square. Not only the kinetic energy at the top, but car has some height, so the car also has a gravitational potential energy, mgh. So this is the total energy at the top of the loop. When the car is coming down, all the gravitational potential energy is converting into kinetic energy. So at the bottom, the car has only kinetic energy, which will be half of m vb square. And law of conservation of energy says these two types of energy should be same. So we are going to write half of m vb square is equal to half of m vt square plus mgh, and you can take m common and then cancel. So I'm canceling m overall, and because we need to make vb subject, so we need to times 2 for the whole equation like this. If you times 2, then this 2 and this 2 will be cancelled. So overall new equation will be VB squared is equal to VT squared plus 2GH. Now you can substitute the value. What about the VT? VT has equation RG, VT square root is gone. So you can say that VB square is equal to RG, because VT square plus 2GH. Now substitute the value. So R is 0.15 times of G plus 2 times of H, and H is the height. In this case, height is the diameter of the loop. Like this is the diameter, which is 2 times of 0.15. So this is 0.3 G. So VB squared is equal to 0.75 into G, 9.81, and you can multiply and then take the root. So VB would be equal to 2.71 meter second inverse. This is the velocity at the bottom. Part C, the toy car leaves the track at X with the horizontal velocity of 3. X at X. Okay, X is 0.65 meter above the floor. Calculate the horizontal displacement of the car from X when it hits the floor. This is a typical question of projectile motion. So situation is, you have a loop, and this is the point X where you have the car is leaving the track, and the loop is at on the table, something like this. So what happened? The car leaves the track and it hit the ground, something like this. So you need to find this horizontal distance, S. That's what they are asking. And this point X is 0.65 meter, 0.65 meter above the ground. So what is the idea? Because we know that in horizontal motion, horizontal velocity stays the same. So this S is can be found is using S is equal to UT, and use the velocity, horizontal velocity, that we have already found, or in fact it is given 3 meter per second. But we don't have time for how long it takes to reach the ground, and for that time they gave us vertical height. So we are going to use S is equal to UT plus half AT square first to figure out T. And in this case, this whole equation is all about vertical motion. So this S is a vertical height, 0.65, is equal to, at that point, there is no vertical motion in the car. So this U is different than this U. In this equation for projectile, this is horizontal velocity, while in this equation, this U is a vertical velocity. For that particular case, the vertical velocity at that moment is 0. So the whole term becomes 0. So we have only half. I'm just writing here, this is becomes 0. So half A is acceleration due to gravity, vertical motion, 9.81 times T squared. Now you can rearrange this equation for T, and if you solve this for T, so T will be equal to 0.36 second. This is the time for vertical height, or this is the same time you can use for vertical for horizontal distance. Now S is equal to 3 times of 0.36. That means S is equal to 1.08, or S is equal to 1.1 meter. This is the horizontal distance of the car. Thank you very much. Have a nice time.